Hi, Assalamualaikum everyone, and Dr. Khairul. We are from Group 8, gonna present about Fourier Transform Infrared Spectroscopy, FTIR.
Ftir are Fourier transformation. This is used to identify organic and polymer. Ftir instrument will send infrared radiation about 10,000 to 100 cm through sample with some radiation absorbed and some pass through. Absorbed radiation will turn into rational and vibrational energy, and the results that present as a spectrum are from 4,000 cm to 400 cm that show a fingerprint of the sample. Using FTIR are using in industry as a material analysis process, and FTIR meta-analysis detect the problem with the product. Next is can use to identify and characterize the unknown material and contamination on or in a substance, identify additives after extraction from a polymer matrix, and also identification, oxidation, decomposition or uncure monomers in failure analysis investigation. FTIR can be used as a quantitative tool to quantify specific functional group. So, to properly describe the presented functionality, we cannot simply have a lookup on a table to tell what a certain energy band is going to be part of, because the spectrum must be viewed as an entire system and thus requires the most qualified analysis in all the techniques of spectrography.
Hi everyone, my name is Nurul Izzati binti Muhammad Shafi. Okay, as stated, our first journal is about predicting Ftir number in diesel fuels using FTIR spectroscopy and PLS regression. The outcomes from this journal are: first, function of FTIR spectroscopy in this journal. It is used to determine the number of cetane as reliable solution for predicting important quality parameter of diesel fuels. Other than that, PLS can be combined with FTIR to obtain an efficient method for predicting the number of diesel units. And lastly, to find the good prediction for optimal number of latent variable required, it can be done by using the root mean square error of cross-validation values, which can be calculated based on the leave one out cross-validation procedure. For material, this journal only used diesel, while the instruments used are Perkin-Elmer Spectrum 1 FTIR spectrometer, IROS 2000 diesel analyzer, chemometric analysis, and MATLAB and PLS toolbox software. For the result, as you can see in figure 1a, two main absorbances are at 2900 and 2830 cm-1 respectively, associated with symmetric CH3 and CH2 stretch were highlighted. Two other weak bands were observed at 1445 and 1400 cm-1 caused by asymmetric deformation and the CH2 scissor bending vibration respectively. In figure 1b shows the effect of pre-processing of spectra. At figure 2, the first three LVs shows that the absorbances at 2900 and 2830 cm-1 caused by the CH3 and CH2 symmetric stretch had the highest weight.
Okay, the basic principle of the instrument that we use here in this journal is Perkin-Elmer Spectrum 1 FTIR spectrometer. The Spectrum 1 FTIR system offers high-performance optical bench for accurate results. It is smart, self-aligned plug-and-play modular accessory with integrated self-test routine for quick, predictable, and reproducible sampling. It is also built-in intelligence to control and monitor measurement, alerting the user to potential errors to ensure consistent results. Why why use this instrument and the importance. FTIR are a powerful and non-destructive analytical technique that can afford rapid and effective analysis of sample regardless of their physical state, whether solid or liquid. This accessory make it possible to reduce the volume of sample necessary for this analysis. A simple drop may be sufficient to register the infrared spectrum. FTIR can predict certain number of biodiesel and that address the limitation of the existing model without ignoring the influence of some factors such as degree of unsaturation and number of carbon atoms. FTIR coupled with PLS used to predict 27 physicochemical properties of diesel and kerosene including the city number.
So, let's proceed to the second journal, which is City Water Pollution by Soot Surface Active Agents revealed by FTIR spectroscopy. The outcome for this journal is to investigate and evaluate the water contamination during different episodes of pollution with different symptoms that prove to be generated by the same contaminant source, the soot. FTIR investigation on diesel cars' muffler collected compound proved that the soot is a composite structure where agglomerations of granular phases in the experiment are incorporated in matrix of continuous film phase. Similar spectra were obtained for the particles remain on the filter paper from filtering the forming rainwater from the street of two major Romanian cities. Sulfonic group being identified in both cases. The surfactant structures have also been identified in the FTIR spectra for the continuous phase prepared from the liquid resulted from the same filtration process of forming rainwaters. So next is a basic principle of the technique using FTIR. The apparatus used is a versatile FTIR laboratory spectrometer MB3000. The samples of water components and the soot needed to be prepared for being converted into solid powder. So, rain-forming water sources was filtered to separate the insoluble particles on the filter paper and the compounds that are soluble, miscible with water, particles that form bonds with water, such as H-bond, surfactants that also bind with the water through their hydrophilic region, and that are small enough to pass through the filter paper. This method of separate the compounds was used for FTIR spectroscopy analysis purpose. The soot from diesel engine combustion was FTIR analyzed as it was collected, and also FTIR was performed on separated fraction based on the filtration method, meaning that the soot was mixed with water, left for 48 hours and then filtered, resulting particles on the filter paper as a solid phase and a liquid phase that could contain soluble, miscible compounds with water, particles that form bond with water such as H-bonds, van der Waals interaction, surfactants that also bind with the water through their hydrophilic region and that are small enough to pass through the filter paper.
My name is Nindo Shashalishreena, and now I will proceed about instrument and material that can be used in Journal 2. For material, first we have soot surface active composite, sulfonic group, forming rain, and sodium aluminate. For instrument is versatile FTIR laboratory spectrometer MB3000. Next is result. As mentioned before, this journal is to identify the source that generate at the forming phenomena for the rainwater in two places, which is lacy and porosity, and we have two methods. First, we use filter paper and then glass slide. Okay, figure 1 show compare FTIR spectra of solid phase retained on the filter paper for soot SWD and water sample DFP, DFI, and detergent. SWD stand for soot wash dry, DFP stand for dry filter lacy, dry filter Poistis, and DFL stand for dry filter lacy, and DETU is a detergent. The sp2 CH bond detected at 2922 and 2848 cm together with the two peaks from around 1640 and 1440 cm confirm the existence of aromatic groups including benzene in four materials, which are DFP, DFI, DETU, and SWD. For figure 2 show the compare FTIR spectra of solid continuous phase found on the glass slide after evaporation of water from the liquid, after filtration of rainwater LFI and LFP, and after filtration of liquid resulted from washing the suit with water, SW, and detergent. LFI stand for liquid filter lacy, LFP stand for liquid filter Poistis, and SW stand for soot washing water. The spectra of sample from figure 2 represent evidence of surface active agent bonding with the water. Why use this instrument and the important? FTIR is capable in detecting chlorinated aliphatic hydrocarbon and chlorinated aromatic hydrocarbon level in water contaminant as low as part per billion. FTIR also can be used to detect diesel water in water pollution.
Journal 3 is diagnosis of normal and malignant human gastric tissue samples by FTIR spectra combined with mathematical model. Here, I attach a front page of the journal. Outcome of the journal is to diagnosis of gastric cancer using ATR FTIR spectroscopy. FTIR attenuated total reflectance ATR spectroscopy is a new, non-invasive, and accurate diagnosis and screening tool. Data modeling was performed based on the Principal Component Analysis (PCA) Support Vector Machine (SVM) K-nearest neighbor algorithm (KNN) on the spectra of 60 fixed gastric tissue samples. This FTIR spectroscopy requires only a small amount of a sample and enables non-destructive analysis by a simple procedure of structural and chemical or physical properties of samples at the molecular level. Materials and instrument used in this journal is paraffin, xylene, and acetone. The instrument that used in the journal is Miracle TM Single Reflection ATR. The PIC Miracle TM is a universal ATR sampling accessory for analysis of solid, liquids, paste, gels, and interactable materials. Second, WKF 510 IR spectrometer. The spectrophotometer is controlled by a computer. Switching between internal and an external light beam allows the use of special accessories such as IR microscope. Here, there are two pictures of Miracle TM Single Reflection ATR and spectrometer WKF 510.
This is a result of the research where the normal spectra and malignant spectra was compared side by side. From what we see, the cancer spectrum on the left side, the distinguished peaks are mainly related to the amide, tree, and protein structure, lipids, and fatty acids. The Rossi curve analysis of these peaks show a reasonable accuracy to discriminate gastric cancer samples. Basic principle of the technique: WKF 510 FTIR spectrometer can provide higher stability and less sensitive to vibrations and thermal variations. The spectra for the samples were collected using Miracle TM Single Reflection ATR. IR data is collected and processed in transmittance and absorber modes. Why use the instruments and the importance? FTIR spectroscopy can display biological change in disease cells and tissues during the process of carcinogenesis and has been widely used for cancer diagnosis. FTIR spectroscopy requires only a small amount of samples and enable non-destructive analysis by a simple procedures at the molecular level. FTIR spectroscopy is useful as a screening tool for gastric cancer based on mathematical data manipulation technique.
I attached the reference for each channel.